Next, let's turn our attention to the PAB and see how we can do the same that we did with the CLI with the PAB. And the page I'm looking at here also gets generated with this build and serve docs command that I always use to get to the headoc documentation. And here we see that there are various deployment scenarios for the PAB. So the one we'll be looking at today, because that's already supported, is the so-called hosted scenario, or WBE. And the way that works is that on the server, which in this case is my local machine, we run a node, so that I'm already doing. Then in addition, we'll have to run a Cardano wallet backend, which by the way is the backend that, for example, the Daedalus wallet also uses. Then we have to run a so-called chain index, and we have to run the PAB itself. So the chain index is something like a lightweight version of dbsync, and dbsync is a way to save the whole blockchain, all the information contained in the blockchain, in an SQL database. So the chain index is somewhat similar, and it will allow us to do things like look up the datum belonging to a given datum hash. So the Cardano node can't do that. I mean, it validates transactions, so at some point when, for example, a transaction tries to spend a script input, it has to provide the datum corresponding to the datum hash in the script output UTXO. So at that point the node is aware of this datum, but then the node saves it somewhere to disk and forgets about it again. So we can't use the node to look up this datum. The chain index can do that, and it can answer various other queries, and it's needed by the PAB. So the wallet, as the name suggests, can administer wallets, one or more. And those are like proper HD wallets, so you have like an infinity of potential addresses, and also your public keys get derived with each step, so you normally never use the same one again, and so on. So that is needed. And then this hosted scenario means that we have to give the PAB full control over one or more of the wallets. So the funds are handled by the wallet. The wallet knows how to sign transactions, and we basically give the PAB access to that wallet. So in particular, we give the spending password to the PAB. And then you can interact with the PAB. So the PAB has a web interface, HTTP endpoints that are exposed, and then a DApp could interact with it by calling these endpoints. However, this scenario is not very realistic in the real world, because it's quite unfortunate that you need to give control of the wallet to the PAB. So the way it could work is that a user that wants to interact with a DApp that's written like this would need to first transfer some funds to the server, to some wallet on the server, and then the PAB does control those funds. But of course that's not very decentralized and somehow goes contrary to what DApps and blockchain are all about. Alternatively, the user could run all these things himself. So run a node and a wallet backend and a chain index and the PAB. Then it would be secure, but of course that means it can't be a browser-based DApp. Then it would be a bundle of applications that have to run on the user's machine. And those applications consume quite a lot of resources, so lots of memory and CPU. So the really interesting scenario that unfortunately isn't supported yet is the so-called browser wallet scenario, where on the server side we only have the PAB, the chain index, and the node, but not the wallet. And then the way it works is the PAB would create transactions, but it has no way to sign them itself because it doesn't have access to a wallet. So instead it would expose the unsigned transactions on an endpoint, and then from the browser or some other user interface, you could pick up this unsigned transaction and have it signed in the browser using a browser wallet like Nami or Yoroi, for example, and then submit it. But at the point of recording this lecture, this scenario is not fully supported. You can already do this with unbalanced transactions. So if you have an unbalanced transaction, you can expose it like this. But then you need to balance it in the browser, and that is very tricky and not easy to do. So for this to work properly, you have to wait until the PAB can balance and then only expose the balanced transaction for signature. Anyway, so we are concentrating now on this scenario, the hosted scenario. But in order to have anything for the PAB to do, we first need off-chain code written in the contract monad that the PAB can then execute. So let's look at that next.